Sure. So an eclipse happens, a solar eclipse happens when the moon crosses between the Earth and the sun. For this total solar eclipse, the moon is going to completely block out the sun and its shadow will be cast on the Earth. And so if you're lucky enough to be in that path of totality, you're going to see the outer corona of the sun. That's the upper atmosphere of the sun. If you're outside of that path of totality, you will have a partial eclipse, which means you won't be able to see that full totality, but you'll experience a partial eclipse nonetheless. Right. So make sure that you have your solar eclipse glasses handy. They're designed specifically to look at the sun. So actually, when you put them up to your eyes, you won't be able to see anything but the sun itself. If you don't have these solar eclipse viewing glasses handy, you can actually create a pinhole projector so that you can see what the shadow of the sun is casting down through that pinhole projector. If you don't have that, things around the house work too. So you can get a colander, something that has a bunch of little holes in it, or you can make your own by kind of bringing your fingers together and letting the sun shine through. So the 2017 solar eclipse, first of all, it had a different path across the US, and this path, the totality path, is actually going to be wider this time. Totality is also going to last a little bit longer, with maxing out around about 4.5 minutes, and we have more people living within that path of totality. So this time, we have about 31 million people who live across that path, which means hopefully we'll have more viewers for that total solar eclipse as well. Absolutely. So, the first thing that you can do is experience your eclipse and talk about it as well. Talk about that experience and what it meant for you. Now, NASA has several projects that you can actually get involved with as well. Globe Observer is the first one, and that is a way to actually track what the temperature and the cloud coverage is at your location to report that out and help us to understand how the eclipse impacts weather that we experience here on Earth. Now, Sun Sketcher is another project that NASA is offering where you can actually help us to determine kind of the shape and the size of the sun during the eclipse as well. And then finally, soundscapes. So sounds change during the eclipse. And what I mean by that is that wildlife and nature around you may change. And so you have the opportunity to really help us to understand what those sounds are that you're experiencing, whether birds kind of start to nest and chirp and go in, if the crickets come out as well. So, as you said, during a total solar eclipse, it's one of the only times that we can really study the upper atmosphere. We have instruments called coronagraphs that allow us to do this on a regular basis. However, it doesn't let us get down into that lower portion of the corona as well. So, scientists are really looking to understand kind of some of the wispy structures that we'll see, some of the activity that the sun is currently generating, and really just study kind of the dynamics of the sun at that time. Right. So the natural ones are important because they allow us to really understand what's going on lower in the corona. The discs that we get from the coronagraphs, those instruments, the way the light bends around them, we can't get really deep into that other portion of the corona. And so we have to have special experiments during the eclipse that let us study those so that we can really understand how the corona is being heated, how particles are being accelerated out to space as well. Right. So for this eclipse, I am excited to compare it with my other eclipse experiences. I was able to view the total solar eclipse in 2017, and then I was able to view the annular eclipse that just took place in October of 2023. And what I've learned is that each eclipse feels different, not only because they might be different kinds of eclipses, but I'm located somewhere else. The people around me are different as well. And so just kind of comparing all of these experiences is what I'm looking forward to. Yeah, absolutely. So, what we've been talking about is a total solar eclipse when the moon comes between the Earth and the sun and completely blocks out the sun so that we can see that upper atmosphere of the sun. Now, an annular eclipse happens in the same way where the moon passes between the Earth and the sun. The difference is that the moon is actually going to be a little bit further from the Earth and it's not completely blocking the sun. So, for an annular eclipse, we're left with a ring of fire in the sky. Now, a partial eclipse is something else that we can experience where the moon will block the sun, but not fully. It won't fully cross over in between, and so just part of the sun will be occulted. Then we also have lunar eclipses where, in this case, the Earth is between the moon and the sun, and those can occur quite frequently as well. So the sun goes through an 11-year cycle of activity. It goes up to maximum where it peaks in activity. There's more solar flares. There's more radiation coming off the sun. There are more coronal mass ejections. And then in that 11 years, it reaches maximum. It comes back down to minimum. And so right now, we're at the point where we're actually reaching solar maximum and seeing that enhanced activity as well. Yeah, so the viewers can visit go.nasa.gov/eclipse 2024, and that will give you all sorts of information about viewing the eclipse, how to safely view it using those eclipse viewing glasses, and also looking for the map so that you can identify that path of totality. Now on X, you can go to @NASASun to see some of the posts that we have on social media as well.